The last section is multi-step synthesis. What is that? This is actually a process where we use more than one step in order to carry out a reaction and form the final product. So with these types of reactions, what normally is asked is you are given a reactant and you are given a product. And you're asked, go ahead and find the reagents that are necessary to go from step A, from product or from reactant A to product B. The reagents that you might use can be either in 1 step, 2 step, 3 step, 4 step. It really depends. For us guys, we're going to keep it really simple. So it's going to be just a 2-step reaction. And every step will use its own reagents in there. So how do you solve a question like this? This is actually a buildup of the reactions that we are introducing in every chapter. So you will be using those reactions and combining them together. So let's say, for example, in this one, I'm starting with an alkene and I am forming a carbonyl. So you got to ask yourself, okay, my type of carbonyl over here in the product, always look at the product, okay? And this is called retrosynthesis. You just work backwards from the products in order to get to the reactants so that you can know the reagents that you used throughout the process. So I'm going to look at the product and see what product is this? What did I do? What did I change from the reactant to the product? Well, the reactants had an alkene in them. In the product, I no longer have an alkene, but I introduced a carbonyl. What type of carbonyl is that? This is a ketone. So the first thing you analyze is that, you know what, I am making here a ketone in there. Well, ask yourself, okay, what are the reactions that I know that make a ketone? So I'm going to work backwards. You know that ketones, see, I'm going to work backwards in this case. So I want to find the reactant here that I am going to react with something in order to get this, okay? So I know that ketones are made from secondary alcohols. So all I need to do is change that carbonyl, just work backwards, change the carbonyl into a secondary alcohol, change it into an OH. So here you go. We have our reactant. This is a cyclopentane, not a cyclohexane. So that is a cyclopentane in there. And on that carbon, this is a secondary alcohol. So that one is my secondary alcohol in there. So this one is a secondary alcohol. Okay. And that secondary alcohol, okay, so now I ask myself, what are the reagents that I can use in order to go from a secondary alcohol into a ketone? Well, I can use either the mild oxidizing agent or the strong oxidizing agent. Any one of those. Just pick one, okay? So here I'm going to use the PCC in presence of CH2Cl2. Guys, you need to know your reagents. So you have to know those in there. I took care of this step in here. Now I want to go from the reactant to the secondary alcohol. So from here, from the reactant to the secondary alcohol, what did I add? So you look at what did you lose and what did you add. Your reactant had an alkene. Your product here does not have an alkene, but instead it has a hydrogen on this carbon instead of the alkene. It does have a hydrogen on this carbon. Actually, I have a hydrogen over here. I have a hydrogen there. So what you did is you simply added a hydrogen on the carbon and you added an OH. Okay. So what is this reaction called? This reaction, we went over it in the alkene chapter, which is called a hydration reaction. And those two carbons are the same degree of substitution. So I can do hydration following Markov-Nikov. Hydrogen adds to the less substituted, OH adds to the most substituted carbon, and my reagents in this case. So I can go from the alkene into the secondary alcohol by simply doing a hydration reaction. Please review this reaction. This is in chapter 12. Please review that. And this is going to be a Markov-Nikov. And here it doesn't matter if it's Markov-Nikov or not, because the carbons are the same degree of substitution. So it really doesn't matter if the OH goes here or the OH goes there. It doesn't matter. But still, Markov-Nikov, hydrogen is going to add to the less substituted carbon, and the OH is going to add to the most substituted carbon in that case. And I will end up having an addition of the OH and the hydrogen. The reagents that I'm going to use for this reaction are H2SO4. These are the hydration reactions that we talked or reagents that we talked about. So H2SO4 in presence of water. So in order to answer this question in here, I wanted the reagents. This is going to be step 1. So I do have step 1 reagents. So these are step 1 reagents here. And these are step 2 reagents in there, which is the PCC in presence of methylene dichloride or dichloromethane. So I can arrange them like this. This is what I want. All I want are the reagents needed to go from the reactants to the products. So step number 1, I am using H2SO4 in presence of water. And instead of that dash, I can go ahead and use a comma as we normally do. Okay. And then step number 2, I'm using PCC in presence of CH2Cl2 in there. And then I can go simply from the reactants to the products. With synthesis, normally you are going to use the reactions that you already know in order to do multiple steps to go from reactants to products. Let's have another example in here. Okay. Now, in this other example, I am starting with a secondary alcohol. So this is a secondary alcohol. And I am getting a product in there. So this is going to be my reactant. And I am getting a product which is a dibromo cyclohexane. This is a trans-dibromocyclohexane. What is the reaction that I know that adds 2 bromines to each other and they are trans? Well, I know that I need to start with an alkene. So I'm just going to go backwards as I did earlier. I'm going to go backwards in there. And I know that I am adding the bromines between those 2 carbons in there. So I'm going to take those bromines out. And to do the addition, I need to have what? I need to have an alkene in there. And the reagents are bromine in presence of carbon tetrachloride in there. And that is enough in order to get the trans addition. Okay? Now, all I need to do is find out the reagents that I need to go from that secondary alcohol into an alkene. And this is called dehydration. So this is called dehydration. This is the reaction that we've talked about in this chapter. It's the loss of water in there, where you are simply using an acid, in this case, which is the H2SO4, and you are doing the reaction at a high temperature, which is 180 degrees. You are using H2SO4. So you are going to end up eliminating, this is going to be the alpha carbon, that is going to be the beta carbon in there that has a beta hydrogen. So you are going to eliminate the alpha OH, you are going to eliminate the beta hydrogen in that case, and you're going to form a double bond in here, which is the alkene. So the reagents that I need for the first step, just go ahead and write them down. It's H2SO4 at 180 degrees. This is going to be step number 1. And step number 2, it's going to be bromine in presence of carbon tetrachloride in there. This reaction happens in steps. The first step has its product, and then the product of the first step will become the reactant of the second step that will react with the reagent in order to get to the final desired product. Now, in this example, I am starting with a secondary alcohol, and I am ending up to form an alkane. Okay, so let's go ahead and count the number of carbons: 1, 2, 3, 4, and 5. Here I have 1, 2, 3, 4, and 5. Same number of carbons in there, except in the reactants, I have an OH. In the product, I have no OH in there. Let's go ahead and highlight where the OH is in the reactants. And here, I have no OH in here. Okay? So what I need to do is that I can easily eliminate that OH and create a double bond in here, because I know that the only reaction that I know to make an alkane is to add a hydrogen in there. But to add a hydrogen, I need to have an alkene. So I need an intermediate in there in the reaction, which is my alkene. This is what I need. I need my alkene to be there, to be present there. So all I need to do is a dehydration reaction, which is H2SO4 in presence of 180 degrees. So I'm going to dehydrate first. This is the dehydration. And in the dehydration, what did I do? I lost the alpha OH and the beta hydrogen. So that is going to be the beta hydrogen. Lose the alpha OH, lose the beta hydrogen in there. And in this place there, I'm going to create the alkene. Now, once I create the alkene, now I can go ahead and add hydrogen in presence of any catalyst that I know, which is like something like a PT or nickel. And in this case, I would end up adding hydrogens here. I'm going to add a hydrogen here, and I'm going to add a hydrogen here. So I'm going to end up getting my alkane in this case. This is exactly the same as adding a hydrogen here and hydrogen there, which is going to be my alkane. So this is the process of making an alkane. The two steps that I used: step number 1, let's draw those. So draw these. Step number 1, I used sulfuric acid in presence of a high temperature. And the second step, I used hydrogen in presence of PT. And there you can put a comma instead of the slash, and that is going to be PT. And these are the two steps or two reagents that are required to go from the secondary alcohol into an alkane.